Hello everyone, in this video we are going to be looking at source conversions. Okay, that means converting source conversions and also Kirchoff's current law. Okay, so the first is how to convert a voltage source to a current source. Now, to convert a voltage source to a current source, the voltage has to be in series with the resistor, with a resistor. So that's the voltage source. How do you know a voltage source? The plus minus, and that's the resistor, is in series with the resistor. To convert it to a current source, the current source will now be in parallel with that resistor. Okay, and current, as we know, is V over R. Okay, so the next we see a question: convert the voltage source below to a current source. So this is a voltage source. We want to convert this to a current source. Now, first of all, we know that the current I, remember, it satisfies the condition that the voltage source is in series with the resistor. So we look for I. Our I is V over R. Your V here is 5, your R is 2, so that gives us 2.5 amperes. So it means this is now a current source. We use arrow to represent current source. Okay, the current source now is 2.5 amperes. Now in parallel with the resistor. And the resistor there is 2 ohms. Okay, in parallel with the resistor. So that's exactly what we have. Now we'll move on to the next, which is converting current source to a voltage source. Now, to converting current source to a voltage source is a reverse of what we just saw. That means the current source must be in parallel with the resistor, and in converting it, it will be converted to a voltage source in series with that resistor. Okay, so you now have your V equal to IR. Voltage is IR. Okay, let's see an example here. Now it says convert the current source below to a voltage source. Okay, that's the current. It satisfies the condition. This current is in parallel with this resistor. Okay, they're in parallel, so we can find our V, which is IR, which means 5 times 4, which is equal to 20 volts. So it means that this source now can be converted to a voltage source. We have plus minus, which is 20 volts. Now in series with the resistor, with the 4 ohms resistor, that's the 4 ohm resistor. Okay, so that is it with voltage conversion, converting current source to voltage source and voltage source to current source. Okay, so we'll move forward to Kirchoff's current law, which we can in short form KCL. Now, the Kirchoff's current law states that the algebraic sum of current around a junction is 0. That's what we have here, summation of I equal to 0. Now, but there's another way we can represent that. We can say that the sum of current entering a junction is equal to the sum of current leaving the junction. That's another way we can define the Kirchoff's current law. Okay, so if you look at this example here, you can see that some currents are leaving this junction. That's the junction here. And while some are entering. Okay, so if you consider the ones entering, you notice I2, I1, and I4 are entering, okay, while I3 and I5 are leaving the junction. So here we can say that I1 plus I2 plus I4, which are entering, is equal to I3 plus I5. That's another way you can represent that, okay? Now let's see some examples here. This question here, we are asked to find I1 in the diagram below, okay? So this is the junction. You can see this junction has only 3 amps. Now, according to Kirchoff's current law, the amount of current entering is equal to the amount of current leaving. Now, you notice that your 5 amperes here, this current here is entering. This I1 is also entering, but your 2 amperes here is leaving. So we can say that 5 plus I1 is equal to 2 amperes. That means the amount of current entering the junction equal to the amount leaving the junction, okay? So it means that my I1 is equal to 2 minus 5, which is equal to 3 amperes. Now, what this simply means, okay, minus 3 amperes. What this simply means is that there is rather a change in direction of I1. So I1 is actually not going inwards. I1 should be moving outwards. Okay. So that now leads us further to, let's see examples involving Kirchoff's current law. Now look at this. Use KCL to find the value V in the circuit below. Now I want to note something here. This is a current source, just like we've seen. Now while this is a voltage source, just like we've seen, plus minus. Now but whenever you have this this symbol like this, okay, it means it's a dependent source. Now the arrow inside shows us that it is a current source but dependent on voltage, your 2V. So we actually have voltage source dependent on voltage, voltage source dependent on current, current source dependent on voltage, and current source dependent on current. But in this case now it's a current source that is dependent on voltage. You can see 2V here. This V is the same V that we have here. Okay. Now if we want to apply the Kirchoff's law, obviously this is the junction here. We call this a node 2. So that's the junction. I can call the potential at this junction VA. You're going to see the reason why we do that. Now look at this junction. The amount of current entering, you can see that 6 amperes is entering this junction. This particular current here is leaving this junction. Okay. Now, but there is no symbol of current here. But looking at this resistor, seeing the direction here, plus minus, actually shows that this current is moving this way. Because current, where current enters the resistor is positive, but where it leaves the resistor is negative. Never forget that. So we can have it this way. So we can say that means 6 amperes is entering the junction, but this here, this 2V is leaving, and while this is also leaving the junction. So what does that mean? It means 6 here is equal to, which is entering, equal to 2V. We are still going to define V. Remember, it's dependent, so we need to define V. 2V plus. Now this V here, the current here is V over 1. That's V, the voltage all over the resistor. I is V over R. But instead of representing it that way, our V is also equal to VA minus 5 all over 1. So your V actually is VA minus 5. Why is it VA minus 5? Now, the minus 5 here is because of the direction, plus minus. So your VA minus 5. Okay, so all over 1. So we are going to get here VA minus 5 all over 1. Now this is 6 equal to 2 times, remember my V is VA minus 5. So we have VA minus 5, then plus VA minus 5 all over 1. Okay, so we can open the bracket here. We see here that this will be 6 equal to, open the bracket, you have 2 VA minus 2 times 5 here is 10, then plus VA minus 5. Okay, so we have 6 equal to 2 VA plus VA gives us 3 VA, minus 10 minus 5 is minus 15. Okay, so your 6 here is equal to, okay, 6 plus 15 is equal to 3 VA. So 6 plus 15 here is 21 equal to 3 VA. So our VA is equal to 21 over 3, which is equal to 7. So that means 7 volts. What does that mean? It means that our V, in the question we're asked to find V, it means that our V here, which is equal to VA minus 5, is equal to 7 minus 5, which is, we have as 2 volts.